So we're going to talk about solving equations that are similar to quadratics. That's what I'm going to call it. So things that look like this. So first I want to motivate this lesson. So notice I have x squared plus 5x plus 6 equals 0. So this first equation here, I know how to solve. I could pretty easily solve this by factoring. Now, what we're going to talk about in this video is that I can actually apply similar methods here to these equations down here. So notice they all start with like the first term has a coefficient of 1, the second term has a coefficient of 5, and then all of them have a constant term of 6, and they all equal 0. So these are very similar, but my question is, so if I'm telling you right now that you can apply quadratic methods to these, what is the pattern about these particular equations? And I'm even going to give you a hint. I'm going to tell you to look at the exponents. So what I would love for you to do is I would actually love for you to just pause for like a minute. What is the pattern that you see among the exponents in all of these equations? And yeah, let's just start there and hit play when you think you've written down an idea. Okay, so the pattern here is that in every one of these equations, the larger exponent is double the smaller. So here I've got x to the 2/3, and I've got x to the 1/3. 1/3 times 2 is 2/3, right? Here I've got 1/2 and 1. 1/2 times 2 is 1. Same thing here. Here I have 2. 2 times 2 is 4. And that's actually the pattern that also works with quadratics. So here I technically have an invisible exponent of 1. 1 times 2 is 2. So when this pattern holds, where we have the larger exponent is double the smaller exponent, we are allowed to use quadratic methods. And so what does that actually mean? Well, let's jump into an example now. So here's an example. I've got x to the 4th minus 13x squared plus 36 equals 0. Okay, so notice the smaller exponent, if I multiply it by 2, I will get to 4. So what that means is that this kind of acts like a quadratic. And so we're going to use a method called the substitution method. So let me outline the steps. The first thing that we're going to do is we're actually going to manipulate this equation. What I want to do is I want to make it look quadratic. So to get there, I'm going to declare this new variable u, and I'm going to set u equal to the smaller variable and exponent. So in this case, we are talking about, so I've got x to the 4th and x squared. So my u in this case is going to equal x squared. So we set it equal to that. Then I'm going to make u squared, and I'm going to have u squared equal the larger variable and exponent. So this is where you want to make sure that whatever your smaller one is, if you take 2 times that, you get to the larger one, which in this case we do. So what I'm going to do is I'm going to set my u squared equal to x to the 4th. Okay, so let's be clear about this. My u was just equal to this x squared, okay? And my x to the 4th is now being set equal to u squared. Okay, so now that I've done this, so I'm actually just going to write this over on the side. So I'm going to have u equal x squared and u squared equal x to the 4th. Let me clear a little space. And the next thing that I'm going to do is I'm now going to substitute my u and my u squared into the equation. So where I have this x to the 4th, I'm now going to write u squared. And then I have 13. I didn't sub out the 13, right? It was just the variables. And then I have x squared, so I'm going to replace that with u. So look at what this gives us now. So I'll get rid of these colors. Okay, so this equation looked maybe kind of weird. But this equation looks quadratic, right? So I'm literally using the same coefficients. This is just a trick to allow you to rewrite the equation so that like in your brain you can use that Rolodex of quadratic strategies of how to solve a quadratic. So in this case now, how can I actually solve this? Well, this I can just factor. So this will be u minus 9, u minus 4 equals 0. So then I get u equals 9 and u equals 4. So I've solved this quadratic, but I'm not done, right? So the thing about this is that this strategy allows me to take this equation and turn it into something that I feel confident to solve, but we're not done because I'm not solving for u, right? I'm solving for x. So let me make some space. Okay, so I substituted, I solved, and now I'm going to substitute u back with the original smaller variable, and then I'm going to solve. So notice here, so I have u equals 9 and u equals 4. So do I want to replace u or u squared? I only want to replace u. So something I want to note about this is that the u squared will not be needed because when we solve this, we solve for u. We don't solve for u squared. So the only substitutions I make are back to the u. So what I'm going to do is I'm going to have this u makes a double replacement for each solution. So what does that look like? This becomes now, instead of this being u equals 9, this will say x squared equals 9 and x squared equals 4. Okay, so u equals 9 became, because we've u equals x squared, so now replace the u with the x squared. This becomes x squared equals 9. And then u equals 4 will become, so again, it's replacing the x squared. Okay, so here's where everything is. So now that I've replaced this, now I have to say, how do I actually solve these equations for x? And this, I think, is one of the tricky parts of using this method, because when you get to this part, kind of anything goes. So in this case, since this is x squared equals 9, I'm actually going to use the square root property. So I'll take plus or minus the square root of 9 and plus or minus the square root of 4. So my final solutions will be plus 3, minus 3, positive 2, and negative 2. So those are my 4 solutions. I didn't need the plus there, but I just threw it in there. Okay, so this is the technique, and it is a little tricky, so we're going to do a few more. Okay, so moving on to the next example. So now I've got x to the 2/3 minus 2x to the 1/3 minus 15. So notice that the smaller exponent, if I multiply this by 2, I get x to the 2/3. So this means I can use the technique. Okay, so let's go through this together. The first thing that I would like you to do is I would like you to write down, what does your u and your u squared equal? So pause the video for a second, write those down, and then hit play. Okay, so my u is always going to be the smaller of the two exponents. So in this case, my u will be just x to the 1/3, and then my u squared is going to be the larger. So this will be x to the 2/3. So notice this is u equals x to the 1/3, not negative 2x to the 1/3. We don't care about the number. We're just trying to replace the variables. Okay, so now that we've got this, now I want you to replace these x's with these u's. So rewrite the equation and then hit play when you think you've got it. So my x to the 2/3 will become u squared. And then my x to the 1/3 will become u. And so this is the first part that I want you to appreciate. So maybe when you initially looked at this, you thought there's no way that I can solve this. But now that we've made this substitution and you're looking at this, it's like, oh, I can 100% solve this, right? So go ahead and solve for u and then hit play when you're ready. Remember, math is not a spectator sport. So let's see, this will be u minus 5, u plus 3. So my two solutions then will be u equals 5 and u equals negative 3. Okay, but we're not done. So the next thing that I have to do is, where I have these u's, I now make a replacement with whatever my original u was. So now we're going to actually work on solving for x. So I would like for you to replace these u's with whatever you think we're supposed to set up and hit play when you think you've got it. Okay, so I'm just down to u's. So when I get to this step, u squared is gone, right? We don't need it anymore in how we ended up solving this. So this becomes x to the 1/3 equals 5 and x to the 1/3 equals negative 3. Now, this is different from the last problem because in the last problem, we were left with x squared. So maybe I'll just flip back for a second. So I was left with this x squared equals 9 and x squared equals 4. That was because of this particular problem and the u that I chose. Now, in this problem, I had different exponents. So when I set this up, I have a different solving strategy. So at this point, now we've just got to kind of think about what we know. So x to the 1/3 is the same thing as the cube root of x. So to get rid of a cube root, I would cube both sides. So I will cube both sides. So now I get that x is going to equal 125 and x equals -27. So just to review, we're setting our u equal to the smaller of the exponents, our u squared is equal to the larger. We make that substitution to make a quadratic that is easier to solve. We solve it, and then after we've solved for u, we have to double back, right? We have to undo all the substitution, replace it with the x's, and then solve from there. Okay, so let's keep going with this idea. So this one I actually really like because I think it messes with the brain a little. In that, so I've got x minus 2x to the 1/2 minus 8. Okay, so what is the larger exponent here? I'll give you a second to think about it. So I have, there's actually like this invisible exponent of 1. So this is the larger variable and exponent, right? And I think that this kind of can mess with the brain a little bit because like you see a 1/2 here, and I feel like sometimes when people look at this particular problem, they want to default and say this is the larger one, but it's actually not because the larger one is just implied. Okay, so let's go through this together again. So I would love for you to set up your u's and just go ahead and set up the equation with the u's. Let's just check in there. So go ahead and do that and hit play when you're ready. So my u, the smaller exponent, like we said, is x to the 1/2, and then my u squared will just equal x. So this will become u squared minus 2u minus 8 equals 0. Okay, so if you got to this point, awesome. And if you didn't, hopefully you can just see where you got off. So now let's go ahead and try to finish solving the whole thing. So go ahead and solve for u, and then see if you can also solve for x. So go ahead and pause here, hit play when you're ready. So this will factor as u minus 4 and u plus 2. So I have that u equals 4 and u equals -2. Okay, so now where my u's are, I'm only replacing the u's, right? I don't need the u squared. So now instead of having u equals 4, this will become x to the 1/2 equals 4. And then x to the 1/2 equals -2. Okay, so like I said, I always think that once we get to this point, this can be a little tricky because you have to think about the context of the problem now. So I have x to the 1/2. So that's effectively like a square root, right? So to get rid of a square root, I would square both sides. Okay, now that is all good for this first one. So this becomes x equals 16. 4 squared is 16. But in this second one, x to the 1/2 equals -2. When does a square root ever equal a negative number? This actually doesn't happen. So in this particular problem, in the context of what we're solving for with x, I actually can't go any farther than this. So I'm just going to discard that solution because it's just not possible. So these are the things that you have to watch out for and just kind of stay on your toes looking for. Okay, so let's keep going with this, and we can really do anything that we want with these exponents. So I'm going to throw in negative exponents, and it's still going to be the same stuff. So go ahead and set up what you think your u's are. Go ahead and set up the equation, and then just hit play just to check where you're at. So my u, the smaller of the variables and exponents, will be x to the -1, and my u squared will be x to the -2. Okay. So if I rewrite this, this becomes u squared plus 8u minus 9 equals 0. Okay, so this is going to, again, be a little bit of a challenge, but go ahead and try this one all the way. Hit play when you think you've got it or when you get stuck. So let's see, this will factor as u plus 9 u minus 1. So I have u equals -9 or u equals 1. Okay, so I never used the u squared. I just used the u, so my u is equal to x to the negative first. So I have 1 over x equals -9, and I have x to the -1 equals 1. Okay, so now we just have to think about what does it actually mean to be a negative exponent. Anytime you're dealing with negative exponents, you know, don't panic. I think sometimes people like see negative exponents and then their brains just kind of do like one of those like do thing, like, because like it makes sense because I think people just don't like them. But what does it really mean? So like, you know, don't let yourself go into that like, oh my God, panic mode. Instead, what does it mean to be x to the negative first? X to the negative first means 1 over x. So this says that 1 over x equals -9. So if 1 over x equals -9, then what must x equal? X will equal, let's see, well actually we'll bust out the work here just in case you want to see it. So I've got 1 over x equals -9. Okay, so what I could do here is I could go ahead and multiply both sides by x so that I have 1 equals -9x, and then I can divide both sides by -9, so I get x equals -1 over 9. So that's one of my solutions. And then for the other one, so if I do that for here, I have 1 over x equals 1. Well, that will mean then that just x will still equal just 1 over 1. So my two solutions are -1 over 9 and 1. So it is completely up to what type of exponents that you're using that is going to dictate what type of substitution that you make. Now to wrap this up, I just have a little bit of an extension of this idea now. So now look at this equation. I've got x plus 3 squared minus 4 times x plus 3 minus 5 equals 0. Okay, so we can still use the u-substitution idea, but now instead of just using x, I'm going to use, so notice I've got x plus 3 squared and x plus 3. So my u will be the smaller of these, so my u will just equal x plus 3, and then my u squared will be x plus 3 squared. So this is literally just an extension of the idea that we've been talking about. Okay, so if I make these substitutions, so I've got u squared minus 4u minus 5. Okay, this I can solve no problem, right? So this is going to be u minus 5, u plus 1. Okay, and so this becomes u equals 5 and u equals -1. So now, where I have the u's, so I don't need the u squared anymore, so I have my u, so now I'm going to replace u with x plus 3. So I'm left with x plus 3 equals 5, and x plus 3 equals -1. And now to finish solving for x, well then I can just subtract the 3. So it's a little bit of an adventure that you're on when you're doing these. So my two solutions are, oops, I wrote u and I meant x, are x equals 2 and x equals -4. Okay, so I have one more, and I think this would be a great time for you to try this totally on your own. So consider pausing here, trying this, and then hit play when you're ready. So my u in this case will be 2x plus 1, so my u squared will be 2x plus 1 squared. So this will become u squared minus 4u minus 21 equals 0. So let's see. This will factor u minus 7, u plus 3 equals 0. So I have u equals 7 or u equals -3. Okay, so now I replace my u's. So I have 2x plus 1 equals 7 or 2x plus 1 equals -3. So we can go ahead and we can subtract the 1 from all sides. So I have 2x equals 6 or 2x equals -4. And if I divide all sides by 2, I get x equals -3 or x equals -2. Okay. So that brings us to the end of this video. If you found this helpful, consider hitting the like button. And I'll try to post a few more examples if you want to see them. And thanks for watching, guys. I'll catch you in the next video.